This is a simple talking clock for visually impaired users. One button announces the time. A second press announces the date. It's offline, easy to use, and built for everyday reliability. Let me show you.
1:31 p.m. 1:31 p.m. Monday, February 16th, 2026.
In the next few minutes, I'll take you on a quick tour of this project. We'll look inside the device, talk about the design goals, and go through the main building blocks that make it work. I'll also show you how it's built, what parts are used, and how you can set it up using your phone. I have already removed the screws, so let's take a look inside. Here on the right, you can see the main electronics assembly. It's built from several breakout boards that are soldered onto a custom PCB, and the whole module is mounted inside the 3D printed case. On the left side, you can see the bottom part of the device. This is where the three AA batteries are located, and right next to them is a small speaker. The main goal of this project was to keep everything as simple and accessible as possible. The user interface is reduced to the absolute minimum, and the clock is designed to work completely offline. It supports both English and German, runs for years on batteries, and can be configured easily using a phone. From a hardware point of view, it's built from inexpensive breakout modules on a custom PCB, and everything is housed in a 3D printed case. All design files, schematics, and source code are open source and available on GitHub. At the center of the design is an ESP32S3 Pico module, which controls the whole system. The current time is kept by a DS3231 real-time clock with its own backup battery, so it keeps running even when the device is switched off. The spoken messages are stored in the flash memory of the microcontroller and played back through a MAX 98357 audio amplifier and a small speaker. To achieve extremely low power consumption in standby, the entire power supply is disconnected when the device is not in use. A MOSFET switches the battery on only when a time announcement is needed. The converter then generates a stable 5 volts from these three AA batteries. When you press the button, the on-off logic powers up the system, the time is announced, and afterwards the microcontroller switches everything off again. And here you can see the same modules from the block diagram as real hardware on the board. All the main parts are standard breakout modules and are easy to solder and assemble. The only surface mount part is the MOSFET used for power switching. Everything else is straightforward and beginner-friendly. This is a complete overview of all parts used in the project. Besides the electronics module, you can see the 3D printed parts, the top case, the bottom case, and the large push button. There are also a few small hardware parts needed for assembly. The larger 3D printed parts have M2 nuts embedded during printing, which makes it easy to assemble everything using simple M2 screws. The clock only needs to be configured once, and after that, it can run for months without any further setup. To enter the configuration mode, press and hold the button on the bottom side of the device, and then press the Start button. The clock will confirm the
Read
Wi-Fi.
on.
On your phone, open the Wi-Fi settings and connect to the network called Speaking Clock. A moment later, a captive portal will open automatically and will show the configuration page. In the center of the page, you'll find the Set RTC button. Press it. It copies the current time from your phone to the clock and stores it in the real-time clock module. Further down the page, you can see the battery voltage, which gives you a good indication of the battery condition. And at the bottom of the page, you can select the language for the time and date announcements, English or German. That's the Talking Clock project. It's a simple, reliable, and fully offline device designed to make everyday life a little bit easier for visually impaired users. All files, schematics, and source code are open source and available on GitHub, so feel free to build your own, adapt it, or improve it. Right now, I'm working on a TV remote control for visually impaired users. A video about that project will be coming soon. Thanks for watching and see you in the next project.